Okay, Assalamualaikum and greetings to all. So today we will continue the last topic on chapter 4, which is fast Fourier transform. Okay, so first of all, let's look at the introduction. An FFT, fast Fourier transform, is a faster version of discrete Fourier transform and can be applied when number of samples in the signal is a power of 2. FFT lead to more efficient algorithm when dealing with large samples. Okay, that means if you want to have a more faster system to process your system to be more faster when dealing with a very large samples, so FFT is a faster version compared to the DFT. So there are 4 types of FFT algorithm. Number 1 is a divide and conquer. Number 2 is radix 2 FFT algorithm. Number 3 is radix 4 FFT algorithm. And the final one is split radix 8 FFT algorithm. So let's look at the first one, which is divide and conquer. So divide and conquer, first of all, you have to divide the general equation of DFT into even and odd, where letting n equals to 2r for the even index and x equals to 2r plus 1 for the odd index terms. Okay, this is the general equation of DFT, remember? So xk is equals to from n equals to 0 to n minus 1 xn wn kn. So therefore, r equals to 0, from r equals to 0, n over 2 minus 1 x 2r for the FFT, x2r dot wn 2rk plus summation r from 0 to n minus 2 minus 1 x2r plus 1 wn 2r plus 1k. Okay, so we want to remove this constant value, okay, because wn 1k, you can get wnk, wn2r plus wnk times wnk. Okay, we want to split that, so it becomes wnk here. Okay, the rest are remain the same. Okay, and you can see here this is 2r and this is 2r plus 1. So okay, so divide and conquer. Say this is even, yeah, and then this is odd. Okay, where wn to rk is equals to if e exponential minus j 2 pi over n to rk equals to e minus j 2 pi over 2 n over 2 to rk, so it's become wn over 2 rk. So when you solve this, you have to use Euler's equation. Okay, so therefore wxk equals to r0 to n minus 2 n over 2 minus 1 x2r dot wn over 2 from here, substitute in the equation, plus wnk r0 to n over 2 minus 1 x2r plus 1 wn0 to rk here. Okay, and we can simplify it by saying gk plus wnk hk, okay, from k0 to n minus 1. Okay, which is, here is the even term and hk here is the odd term, right? So this is how you want to derive the divide and conquer. And then the next one is radix 2 FFT. So suppose n equals to 2, and for 0 from k is from 0 to 1 because n minus 2 is 1. Therefore, for even and odd, you will get, okay, this is the equation, the one that we already derived in divide and conquer. So you just apply here. So gk, remember this is even, from r0 to n minus 2, x 2R, WRK, and over 2 becomes, okay, so R is from 0 to 2 over 2 minus 1, it becomes 0. So X2, 0, W1, 0. So it becomes X0, E minus J0. Okay, so it becomes X0 at K equals to 0. Okay, now at K equals to 1, so R0 to 0 as well. So X2R. So here, because this one is become R, remember, this one is K, right? So 1 R, okay, n over 2, this is n over 2 is 1, and then remember K is 1, so it's become R, becomes X0, E minus J0 as well. So it's the same result as 0 is K, is become X0. So that means G1, so this is even, okay, for even term, that means G1, G0 at K0 is equals to G1, which is X0. Okay, clear? So K here is, you have to replace from 0 to 1. So 0, 1. And then substitute into the general equation. And then you get the answer X0. So for K equals to 1, the answer also X0. That's why it says G0 equals to G1 for even term. Okay, for the odd term, so 2R plus 1, remember? So it's the same. This is the same just because 2R, so R is 0, plus 1 become X1. X1 E minus J0, so for at K0 is X1. Same goes at K equals to 1, you will get X1 as well. That's why this is for odd. That's why H0 equals to H1. Okay? Okay, for the constant value, so W, N, and K equals to E minus J 2 pi over N K E minus J 2 pi over 2 K E minus J 2 pi K. Okay, so N is 0, right? So K, you have to replace between 0 and 1. So at first, when K equals to 0, so N2 K0 and N2 K1 at K equals to 1. Okay, you can solve it. So E minus 2 pi over 2, K is 0. So cos 0 minus J sin 0. So this is Euler's equation, become 1. And W21 minus 2 pi, 1 over 2, that become cos pi minus J sin pi, it become minus 1. So that's why the value is 1 and minus 1. Therefore, remember the even plus with the constant odd. So it becomes G0 is X0, right? So W20 is 1. Okay, 1. So X0 plus 1 times X1, it becomes X0 plus X1. H0 is X1 for K0. And then for K1, X1, G1 plus W21H1 is minus 1, right? So that's why X0 minus X1 become K equals to 1. Okay, so this is the equation for radix to FFT and how you try to derive it. Okay, the next one, the most important one is draw the butterfly signal flow graph. Okay, so first of all, you have to draw X0, start with X0, and then this is X1. The small x, okay, this x, small x, because this is the big, the capital, the FFT, X0, X1. Okay, and then you know that X0 is G0, right? So G0, okay, plus G0. So this is X0 plus X1. So X1, X0 plus. So draw a arrow here. So this one X0 plus X1. So it becomes X0, G0 plus H0. Okay, for X1, X0 minus X1. So this is minus 1. So become X1, G1 minus H1. So this is how you draw the butterfly signal flow graph. Okay, for radix for FFT. So radix 4, n equals to 4. So k is from 0 until 3. Okay. Therefore, for even and odd, so you have k 0, 1, 2, 3. So gk, so is the same equation. So r from 0 until what? N over 2 minus 1. So 4 over 2 is 2 minus 1 is 1. So r0 to r, so n over 2 is 2. R is 0, right? Okay. R is, no, sorry. K is 0 because k is 0, so it becomes 0. Okay, so R is start from 0 and 2 times 0 is 0, x0, e minus j0, plus x, 2 times 1 is 2. So it becomes x0 plus x2, e minus j0. So e minus j0 is plus 1. So become x0. Okay. So you have to solve this using Euler's equation. Okay. Carry on until you get g1 at g1 x0 e minus j0 e minus j pi, because r is k is 1. So k is 1. So r, this is r0, this is r1. So r1, so it become minus j pi. So x2, x0 minus x2 become k1. So this is the even equation for radix 4 FFT. Okay, and you can see that G0 equals to G2 and G1 equals to G3. Okay, G0, x0 plus x2, x0 plus x2, and this is G1 equals to G3. Okay, and for the odd part, okay, so 2r plus 1, so it's become x1 because x0 to r plus 1, 0 plus 1 is 1, and then 2 plus 1 is 3. So x1, x3, k0 until k3. Alright, so, and finally we'll get h0 equals to h2 and h1 equals to h3. Okay, this is how you derive it, everything. Okay, for the constant part, so w and k, so it become e, n is 4, 2 pi k, so you become e minus j pi over 2k. Okay, and then you substitute from k0 until k3. So it's w4 0, 4 1, 4 2, and 4 3. So it become 1 minus j minus 1 and j. Therefore, you will get x0 is g0, w4 0, h0. It become x0 plus x2. Okay, this is g0. And then this is 1. Since it's 1, so x1 plus x3. Okay, for x1, it become x0 plus x2. So this is minus j. So minus j bracket x1 plus x3 for k1. Okay, for x2, g1 plus w4 to h2. So it become x0 plus x2 minus x1 plus x3. K equals to for k equals to 2, and finally x3 become x0 plus x2, j x1 plus x3, k minus 3. Okay, k for k equals to 3. So this is the butterfly signal flow graph radix 4. Okay. So how to draw this? So remember, this is small, there is the input, so start with even first. So x0, x2, x1, x3. Okay, x0, but the output will be x1, x0, x1, x2, x3. Just the input, you have to be alternate so that we can draw it nicely. So x0, okay, it meets with x2, so x0 plus x2, okay, and x0. Because this is 1, so 1. So you have to draw this correctly, okay? So you have to put the correct what we call this, minus 1 here, 1 minus j, so you have to label it correctly for you to get perfect marks, because normally when the question asks you, you have to draw until the butterfly signal flow graph. Okay? Okay, I will continue the next one after this. Okay.